Hey everyone, welcome to our video on X-ray crystallography. We're going to have a really brief overview today of what the process is and some information about it. So just a general summary of crystallography and the reason we use it. It has to do a lot with uh, the types of molecules that we're considering. We often bring this process out when things like NMR and IR and MS maybe don't really give us as much information as we'd like. And this can be the case when we have molecules that are cis or trans, for example. And we know what the functional groups are, but the only difference between them is maybe their spatial orientation. And that's what X-ray crystallography takes a look at. So the concept behind it is, again, to determine the molecular structure using X-ray diffraction patterns. And it tells us information about things like stereochemistry and bond length, but however, it does not tell us information about things like the molecular formula, things like how many lone pairs the atom has. And the reason for that is because X-ray crystallography is very much focused on the atom in space and the electrons that surround it and where they are around the atoms and around the molecule. So the way it works is you basically start off with an X-ray source, something that can shoot some X-rays out. It goes in, strikes something called a collimator or monochromator, which basically converts all of these crazy X-rays into a single X-ray beam. And then this single X-ray beam strikes some crystal. This could be, for example, some kind of protein or maybe like DNA, and it strikes this molecule. And then this causes it to basically diffract, and this diffraction is caused by electron clouds, and this creates a lot of crazy diffraction over here that basically registers on a type of film. And these things create some kind of pattern. For example, I'm just going to draw something kind of random here. These diffraction lines create some kind of pattern that registers on this film, and it builds and builds and builds, and you basically rotate this crystal or whatever compound that you're looking at in different angles. You shoot the X-ray beam at maybe this point, maybe you shoot it again at this panel here, and you basically do it from all different angles, so that way you can get a bunch of different diffraction patterns. And so in general, since we're dealing a lot with electron clouds, a good concept to know is that the higher the atomic number of the element that we're dealing with, the greater the diffraction or more diffraction. So you basically have more diffraction when you have a higher atomic number. And the reason for this is, if you remember from Gen Chem, the greater the atomic number, the greater the number of electrons, the bigger the electron cloud, and so you have more electrons you're dealing with, so this leads to more diffraction. And so that's something to keep in mind. And the reason we do X-ray crystallography is it tends to be very helpful for small types of molecules where, again, NMR and IR don't really provide us with as much information as we would like. And so with X-ray crystallography, we can get something called an electron density map. And this is what it looks like, and it basically gives us information about where along the molecule a lot of the electrons are. So the peaks, this looks actually like a lot like a topographical map, and so these peaks represent basically where most of the electron density lies in the molecule. So if I were to maybe color those in, you can see that there's some kind of structure along here, maybe some kind of structure here, and so on. So this gives us information about where the electrons lie in the molecule, and you can imagine this is kind of like a slice or an image, a 2D image of the compound in question, if we were just to simply maybe cut down into the pi cloud and look at it, kind of like an MRI image, if you've seen one of those, where you just kind of cut a slice into the brain and see what it looks like from a 2D perspective. That's kind of what it is with this atom here. Okay, so those are the very, very basic concepts of X-ray crystallography. Again, it's not really a big component of organic chemistry. It's not as important as things like IR or MS in terms of the course, but it is a very interesting area of study, and it's really helpful in terms of understanding the spatial information of a molecule. Okay, but just keep in mind it can't tell us things like molecular formula and such because it's more focused on space, basically. All right, so thanks for listening.